Hi, our paper is titled Improving Medical Multimodal Contrastive Learning with Expert Annotations, and it's authored by Yogesh Kumar and Pekka Martinen. We're both from Aalto University in Finland. The modality gap in clip embeddings is an interesting phenomenon. It was found that when we plot the UMAP projection of the embeddings from clip, they form different distinct clusters corresponding to their modalities. So, for example, images and text form separate clusters, and it was observed that this also transfers to other type of clip, like when we have videos and text, and also in medical domain, for example, when we have chest X-rays and the radiologist reports of the corresponding X-ray. The downstream performance of medical imaging models can be improved by first pre-training them on clip objective by pairing the chest X-ray and the radiologist report. We wanted to explore whether this could be improved further by injecting some higher quality information. Specifically, we wanted to use the eye tracking data of the gaze patterns of a radiologist while they were observing a chest X-ray. So, for example, you could get like a heat map of the different regions that the radiologist viewed while they were observing it. And we used that to create an additional modality we call expert image. And we see that when you project this onto the shared embedding space, we obtain three different clusters. The heat map processor is the module that we use to process the heat maps from the eye gaze data and the images. And it is a single layer of multi-headed attention. And the reason why we keep this shallow is so that we make sure that the embedding obtained from the expert image is sufficiently distinct from that of the original image so that we get three different clusters. So essentially what we're trying to do is to create an additional modality, and then we utilize the modality gap to create additional pairs for the contrastive loss. So if you look at a typical clip model and say we have three different pairs, we obtain one positive pair, and for each positive pair, we obtain two negative pairs. But in eClip, since we have three different clusters, for each image and its text, we obtain two positive pairs, one from the image and text, and the other from the expert image and text, and we obtain four negative pairs. So this means that when we try to minimize the info NC loss, we get better convergence trends compared to regular clip because there are more samples available, more pairs available for optimization. And for experiments, we performed a zero-shot image classification of the image encoder that was trained on clip loss. And we compared this for four different data sets. And we see that the expert annotated clip outperforms the regular clip. And we also perform experiments on sample efficiency where we artificially restrict the amount of training data that's available during pre-training and then plotted the corresponding zero-shot classification accuracy. And we see that the eClip model shows better trends compared to clip on different data sets.